In this recording, I'm going to show you one of my standard demos that I'm doing in several of my presentations right now, and it's related to using these two Intel Edisons and the Apache ActiveMQ message broker over MQTT. So basically what happens is I have a sensor here, the TI SensorTag specifically, that feeds its data via Bluetooth into the Intel Edison, which uses Node.js to grab that data, wraps it as an MQTT message, sends it out over Apache ActiveMQ, and then I have an Apache Camel process that's evaluating that data and determining if it's hot or not. You know, is the temperature hot or not, right? Hot or normal. If it's hot, it adds another message to another message queue out here on ActiveMQ, and then this other Edison will look for that data, and if it's hot, it basically drives a servo through a Lightblue Bean. So the Lightblue Bean is specifically this guy over here, the Lightblue Bean right there. He's driving my servo. So this Edison and that Lightblue Bean are working in concert together. Basically, he's the client for my message broker running on this laptop here. And then when he sees that there's a hot message coming through, he makes sure he connects to that guy and tells him to turn the servo on. And this guy is just programmed with C code, Arduino sketches, so that it has basically a Bluetooth radio there, and it's looking for messages coming from here, and then it'll determine if it drives that servo. And then this is my other Intel Edison and the TI SensorTag. So he makes a connection from here to here. This is again Bluetooth, just like it is over there. This guy's a Bluetooth radio on board also. But this sensor package here is like 10 different sensors. There's a light meter, a sound meter, barometer, internal temperature, external temperature. That's what I'm using, is the external IR temperature. And there's all sorts of other sensors that are part of this: accelerometer, gyroscope, etc. So it's a very powerful little package. This is a little $29 kit. And then my Lightblue Bean is also $29 kit. And you can see I've soldered on some headers there so that I can then add my little jumper wires, and then I have my little battery to help drive that little tiny servo there. But this little Intel Edison specifically is a little Linux server on a little battery here. I use this because it's incredibly compact, right? I can get a lot going on in a very small amount of physical space, which is good for plane trips and doing presentations. All right, so TI SensorTag, Intel Edison, feeds the data in, Camel evaluates the data, sends out another message where this other Edison grabs and then drives this Lightblue Bean, and then I also have a browser that is actually getting the real-time updates also. So let's see if we can get this working. And so let's get that process going, and I have to punch a button over here to get it connected. So right now this guy is connected to that guy, so I'm SSH'd into here. That's what you see here, and he's connecting to here. And you can see there's the temperature going up. If I put my hand over it, you'll see it shoot way up. And take my hand away, it'll fall back down. And if I put my hand over it again, you'll see the temperature shoot way up. And I take my hand away, you can see it fall back down. And then if I have here's my little dashboard here. Again, I can put my hand over it, and you can see the temperature shoot way up. And then let it fall back down. So if I run my Camel process now, so my Camel process is running here. This is my ActiveMQ broker, so everybody's connected into him. So you can see so basically it's looking at the actual temperature, numeric temperature there, so 18 degrees Celsius, which says it's normal. If I put my hand over it though, you'll see it shoot up beyond 20 something, and then it decides it's hot. Take my hand away, it should go back to normal. Okay. So now I need to connect, so all that looks like it's working. Now I need to connect this other guy. Okay, so this Intel Edison now connects to this Lightblue Bean. If it all goes well, the green light turns on, and you can see there's the normal messages coming in, so everything's normal. But if I put my hand over it, it should get hot. And then you can see the servo going crazy, right, to indicate it's all hot. And if I take my hand away, it should calm down. And you can see it goes back to green. So basically, I put my hand over it. This sensor, it gets hot, sends a message out to the servo. You should see a little blue light here too, because that's programming I've done. So basically, after it's done, this little animation with the servo goes back to blue, and then back to green to indicate it's ready for the next message. So in this case, all of this is happening, and again, you can see here in my browser, it's all happening through the message broker and MQTT messages, again, coming from this TI SensorTag to this guy over here. That's getting the raw message data in, the raw message sensor data in. And then if it's hot, Apache ActiveMQ is making that determination over here. And then, if in fact it is hot, the message comes out to this guy, which hits that guy, which tells that servo to turn right there. So those three things are working together. You can see there's the battery pack for it. So let's try it one more time. Put my hand over it, and there goes the servo going crazy to indicate that it's hot. All right, simple demo, but it actually shows a fair bit of complexity and how you can connect all these components together. These two little Linux servers here are operating as my basic gateways, running a Node.js process, communicating over Bluetooth to these other two devices, the TI SensorTag and this Lightblue Bean. And they're basic little MCUs that have some basic code on it. This is code that I have written here. In this case, the TI SensorTag comes out of the box ready to provide sensor data. And this is just using standard Node.js NPMs to grab that data. All right, well, that's it for this presentation.